managing and troubleshooting security. So in this nugget, we're going to take all the things that we haven't really covered in great detail when it comes to security and talk about it. Things like permissions, securables, applying the principle of least privilege, working with schemas, and then troubleshooting security. So we'll kick this nugget off here by getting into the virtual nugget lab and learning how to manage database permissions. We'll apply the principle of least privilege at the role level and the individual user level. Take a look at some best practices there. We'll also take a look at how to work with permissions, securables, and scope. We'll also take a look here at how to work with schemas. Schemas are a great tool that can greatly simplify security, and you'll see them used all over in the AdventureWorks sample database. And really what they are is they're just a collection. Think of it as a container for objects in SQL Server. So anything that's a securable can be put inside of a schema. We can then create a database role, and we can make the owner of the schema this database role. Now, any user we put in the database role will automatically have access to any of the objects inside of the schema. So we'll get a good example going so you can see schemas in action. Finally, here we'll take a look at how to troubleshoot security. We'll start with authentication issues. A user can't log in, or an application's getting a timeout error. What are some of the common things to look for in SQL Server so we can figure out what the problem is? We'll also take a look at endpoint troubleshooting. And I know we haven't covered endpoints yet, but we will, especially when we get into database mirroring, always on availability groups. And just think of an endpoint as a communication channel, a dedicated communication channel for a specific feature like database mirroring. A database mirror is going to span multiple SQL servers, or I should say another SQL server. So they'll get their own communication channel. So we'll need to ensure that they're configured properly on both sides. So that's really all endpoints are. And the biggest uses for endpoints are that database mirroring, always on, and the service broker. So we'll talk a little bit about those pieces when we get there. And I'll also show you how to work with certificates and keys. Less about troubleshooting, more about ensuring that you have a backup and you have them in a secure location. Because if anybody were to get a hold of our keys, or if we were to lose our keys and then something were to happen to our database, our data would pretty much go kaput on us. So we'll take a look at some best practices there. And I'm also going to show you how to use certificates and keys to encrypt data at the column level. So nothing that you'll have to worry about exam-wise. One of those kind of super useful real-world things just to show you how to do it. Because it's neat and it's easy to do, and again, it's incredibly useful. We took a look in a previous nugget how to use transparent data encryption to encrypt a database. So why not take a look at how to put these certificates and keys to use to encrypt a column of data. So we're in the virtual nugget lab, and I have SQL Server Management Studio launched. So let's bring it into view. I've added a project into our solution for the series 19-security, and we're going to start with permissions and the right way to do permissions. Now, in a previous nugget, when we talked about logins and users, I showed you how you could take a bunch of users, add them into a role, and then pluck out specific users and either deny or grant extra permissions to them. And while that works for small user bases and small departments, it's not a good idea in general. It's not a best practice. You can do it, but it's not a best practice. The best way to do security is clear separation between your roles. And what I mean by that is let's head into Server Manager, which I also have open down here, and local users and groups, and check out our users. Let's say we have an HR department with 3 HR staff employees, and then regular employees, and then an HR manager. So rather than put all 4 of these logins into a group, and then pluck out our HR manager, give them extra permissions, we should separate them and keep them separated. And if we head to groups here, we should have an HR managers group with our manager in it, and then our HR staff group with our employees in it. And if we get more managers, we just add them into the group, and they automatically get all the permissions associated with HR managers. So we should continue this structure and keep it exactly as it is, bring it into SQL Server, and apply permissions on top of it. That way it's consistent with how our Windows security strategy is set up and how our groups are set up there, and it makes it much easier to apply the principle of least privilege across our roles. So to put this strategy to use in SQL Server, we first need to create our logins here in the master database. This will create the instance level logins associated with their Windows accounts, so we'll bring those into the server. Next thing we need to do is create user accounts in the Nugget Demo DB database. So we'll switch back to the Nugget Demo DB database and create user accounts based on those logins in the database, keeping the names the same. So we'll do that. And now let's start working with the HR staff role or group in Windows. So we're going to make an HR staff role here in SQL Server, and then we'll add a member, our HR staff member, into that role, where we can then start applying permissions to that role. So let's do this part in Transact SQL as well. This will give us all the objects we need to work with. Now, before I show you how to do the rest of this in Transact SQL, and that is work with securables and grant permissions to those securables for this role, let me show you how to do this using the Management Studio interface. So let's expand databases, expand our Nugget Demo DB, head into security, roles, database roles, and there is our HR staff database role that we just created. So right now this role is just a role with a member in it, our HR staff member. So if we head to the securables tab, we can hit search here. And what kind of securables do we want to search for? Specific ones, all objects of a specific type, or all objects belonging to a schema, which you will see will come in handy when we talk about schemas. So let's choose all objects of a specific type. We want to look at all tables. Now let's say that our HR staff group, we want to give them permission to work with our employees table, but there's specific columns or a column or columns in the table that we do not, that's sensitive, that we do not want to give our HR staff permission to. So this is where it's really cool because we can take anything that works with at the column level, like the select statement or the update statement, we can choose it, and you'll see the column permission button will light up. And now we can hit column permissions, and we can grant or deny access to a specific column. Pretty cool, huh? So let's do this. Let's just say something like this. We could say we want to give access to everything except the salary column. We can hit OK, and now our users, if we were to hit OK here, we'll be able to select all the data out of that table except the salary column. That'll be protected from our HR staff, and we could then give full-blown select permission to our HR manager's role so they can work with those sensitive columns. So let's say cancel here. Let me show you how to do this in code. Here is how we can do it in code at the column level. We can see you can grant select, and if you separate them with a comma, you can apply multiple permissions to a single securable at once. So if we highlight all this code, we're going to grant select and update on every single field in the employees table except the salary column. So if we hit execute, that's going to do it. Now let's test this out, and the best way to do this is to fire up another copy of Management Studio. Only we're going to right click and choose run as different user. If you haven't seen me use this in previous nuggets, it's a sysinternals utility that you can get called shell run as. So you can run other applications as other users other than just the administrator. So let's run it as a different user. Let's log in as HREMP. We'll put the password in here, hit OK, and this should fire up Management Studio under our HREMP's security context. Great way to test out permissions and your security strategy. So let's log into our eval instance as our HREMP login here. And if we expand databases, expand our Nugget Demo DB database, and expand tables, you'll notice right off the bat our security is working because we only gave them access to employees. There's also a sales and a sales archive table in our Nugget Demo DB database, and they don't even know it exists because it doesn't show up here. Let's right click and choose select top 1000 rows. Now SQL is going to try to select everything, and we should get an error. The select permission was denied on column salary of the object employees. Cool, so it's working. Now let's take salary out of here and then execute it again, and it works. So our HR staff employees only have access to what they need, and the only access they need is to the employees table. And they only need select permission on a specific set of columns and update permissions on a specific set of columns, and that's all they ever need. So now if we ever have new staff members come in, we just simply add them to the Windows group, and they're all set up in SQL Server. No management required. Now to complete the picture, let's take a look at our manager's role. So our managers are probably going to need full-blown data permissions on our employees table. They're going to need to select, insert, update, and delete, and work with every column in the table. So pretty easy. We can create a role called HR Managers. We can add our HR Managers database user into that database role, and then we can grant permissions to that role based on our employees table, which is our securable. So let's highlight all this code, hit execute, and now if we refresh our database roles over here and go into HR Managers, we can head into securables, and here are all of the permissions that we just configured. So this is certainly the way to go because, again, you get clear separation of responsibilities, and it's a lot easier to assign permissions when that's in place. Now, we know nothing's perfect, especially when it comes to security, and everybody does business a little bit differently and designs their departments differently. But let's say in our HR department we have a power user. We have a power user that's good at writing reports, and they need a little bit more permissions than, say, our staff needs, and maybe a little bit less permissions than our manager needs. Well, in that case, we can add them in individually and micromanage their account, give their specific account permissions. So that still maintains our boundary of separation because we're not adding that user into our staff or into our managers and then giving them extra permissions or taking away certain permissions. We maintain that boundary of separation, which will only help us out when it comes to managing security. And power users like that are few and far in between, so you're not going to have, a lot of them to deal with inside of your databases. Let's move on to schemas and take a look at how we can give access to specific parts of our database. So think of schemas as a way that we can just take an area of our database, a group of tables, a group of stored procedures, a group of functions, tie them all to a schema, and then only give permission to individuals that are associated with that schema or database roles that are associated with that schema. And a popular use for this is developers. Now, rather than give developers who are going to need a lot of access in a database to do their job to create and modify objects, rather than give them full-blown DBO access to the database, which a lot of people do, see it all over the place. Rather than do that, why not give them access through a schema so they have their own sandbox to play in within our database that will affect nothing else in the database? Especially if we have a set of production tables and stored procedures and functions, now they can still work in their own sandbox to extend the functionality and build the next version of the application without affecting the current production objects. So let's recreate that scenario and see if we can give our developers their own sandbox to play in. So here we go. I have our developers group, and by the way, we've got a clean slate here as far as our developers login and user goes. I blew them away at the login and user level in the database here. So we've got a clean slate. Let's go ahead and create our developers login first at the instance level, and then we will switch to Nugget DemoDB and create our user account linked to our login. So we'll do that, and so now they've got access to SQL Server, they've got access to the Nugget DemoDB. So from here we're going to create our role called db_devs, and we'll create our schema called devs. Those will give us those containers to work with. One container for putting our users in, another container for putting our objects in. Now, the other thing we're going to do is kind of interesting. Let's say that we still want to give our developers rights to work with the data in objects outside of their schema. So DBO being, let's say that's where all of our other objects exist in the DBO schema. So we can give them select, insert, update, delete, and references permission on the DBO schema, meaning all the objects associated with that schema, so they can work with the data, they can join tables, their own tables to these tables in the DBO schema, but they won't be able to alter the tables. They won't be able to drop them or create any objects inside of the DBO schema, just simply work with the data inside of them. From there, we're going to alter our role, dbdevs, just to get our developers user inside of that role. And then we're going to grant permissions to the role, create table, create function, and create procedure. And since they're tied to the dev schema, this means they'll be able to create tables, stored procedures, and functions inside of that schema. So let's highlight all of this code and hit execute. And there we go. So now we have everything set up. I'll also show you you can transfer objects that are in one role to another role. So if we want to take our get current user stored procedure and transfer it so they have access to it, we can just do an alter schema dev and then transfer another object into it. I'm not going to do that right now because I want to show you what it looks like when they don't have permission to something. So let's see where that got us. And we're going to fire up yet another instance of Management Studio, only this time under the security context of a developer account. So let's log in as our wacky developer. So wacky, they spell it with an X, waxy. Wacky developer, there we go. Put the password in. And now I know we're going to have one little issue, but it was by design. Since we removed and started with a clean slate and re-added our developer login at the server level, we took away all their existing permissions. And because back in our, when we talked about how to create logins and manage logins and server roles, we actually took away view any database permission from the public role. And right now, our developer's login only has access to the public role. So look at that. We can't see any databases except the one that the wacky developer created because they're in here also by themselves as a login. So what we need to do is give access to, back to, I should say, our developer login here. So let's go back into our primary instance that we were in, head down to security, head down to logins, double click on developers, head into securables, and let's give view any database permission back to our developers account. So we'll hit OK, flip back to our instance that we were working with, right click on the databases, and hit refresh. There we go. Now we're good. Now let's expand Nugget DemoDB and tables, and I also want to expand programmability and show you that stored procedure. Look at this. See this little lock? That's a good visual indication that we don't have access to it. We cannot do anything to this get user account as a developer or get user stored procedure as our developer account. We can't execute it. We can't view the definition. We can't do anything. It's locked. But we can do stuff to our tables because there's no lock. So you get a good visual indicator of what you can do and what you can't do. So we can grab data out of this table because we have select permissions on it. But again, we wouldn't be able to do really anything else outside of working with the data. Pretty cool there. Now, what about creating our own object? Well, I'm just going to, let's just say we wanted to make a copy of the employees table. I'm going to right click, head into script table as, create to, new query editor window. And the only thing we need to do here is switch out our schema because we belong to the dev schema. So if we do that and hit execute and refresh our table view over here, check it out. Now we have our own copy of the employees table. Only this time we have full control over it. We can add fields, take fields away, change data types, do whatever we want to do in this table. And then on the other side, let's say we did want to transfer the stored procedure over to our developer group and our dev schema. We can just run our statement that'll alter the dev schema and transfer that object over. Now if we switch back and refresh on our stored procedures, we lose the lock, and now we can execute it, modify the stored procedures because you can see it belongs to the dev schema. All right, why don't we head back and take a look at how to troubleshoot some common areas when it comes to security, authentication, endpoints, and certificates. And let's start here with authentication troubleshooting because that's going to be the most popular area of troubleshooting security. People can't log in. What do you do? Well, it could be an invalid user. And if that's the case, we need to check to make sure they have access, check to make sure their account is enabled, and check to make sure their account isn't locked out from too many invalid attempts. Also, invalid password, a popular one. From there, if it's a SQL user, we can reset them inside of Management Studio here pretty easily just by going into your account and then resetting the password. You have to specify the old password if you're going to reset it. And then if it's in Windows, you'll have to work with your administrator to have them reset it from there. Another one here is if they are logging in as a SQL Server account, make sure that you have mixed mode enabled. You wouldn't believe how many people just run through an installation and choose the defaults, and then default is Windows authentication only, not what we call mixed mode, which is both authentication methods. So you can enable that at the instance level. And then also connection issues. If applications are having problems connecting, users are having problems connecting, make sure that the SQL browser service is running. Because if that's disabled or if it has problems with the account that it's running under, then nobody will be able to find SQL Server on the network. Also ensure that the proper client protocols are enabled, something you can do in SQL Server configuration. And also make sure that they're in the order that you want them to be in. All right, let's move on to endpoint troubleshooting. And first, before you can troubleshoot an endpoint, you have to know what it is, right? Think of an endpoint as a point of entry into SQL Server. It's a custom point of entry when it comes to us creating our own endpoints because we can define the port, we can define what IPs we want to listen for, and then we can define our security, our authentication method on that endpoint if we want to support encryption. But there's a lot of uses for endpoints. The big ones being if you want to separate traffic, maybe you want to monitor traffic on a specific part of SQL. What we can do, or for a specific application, what we can do is we can set up an endpoint, put it on a specific port, and then tell the developers in their connection strings when they connect to SQL Server also specify the port that they're connecting to, and that'll flow all traffic from an application then through that endpoint. So that's one popular use, directing traffic through our own custom created tunnels. Another popular use, and one that we'll actually have to do if we use specific features of SQL Server, especially if you use always-on availability groups, database mirroring, or service broker functionality, then we'll need to set up and create our own endpoints. Because these are features that use multiple SQL servers. So take database mirroring, for instance. We're going to have a primary mirror and then our partner. And they're not going to be on the same server. That would defeat the whole purpose of mirroring. They would be on different servers. So we would need an endpoint on each server so they could communicate through those endpoints specifically. And we actually have that scenario set up right here. Now, don't get too concerned about worrying about the details here because we have an entire nugget dedicated to database mirroring. So we'll go through all of this. And in fact, doing it this way, this simple, if you're not using a certificate for authentication, then you can do this using the interface through SQL Server Management Studio. It'll actually write this code underneath the interface and create the endpoints. We've got a nice interface on top of it to do all of this stuff. But if you're going to do certificate authentication, then you have to use Transact SQL. So we'll get very familiar with all this stuff. But in this scenario, let's say we have 3 SQL servers all on different boxes here. And so we could create an endpoint on each one, and we'll need to also specify the database mirroring role because this is for database mirroring. So by doing that, we have to set up some database mirroring specific attributes, like the role they're playing. So we have two partners and a witness, all using Windows Negotiate authentication. You can also set it up for Kerberos or NTLM. Negotiate will use Kerberos if it's there. If not, it'll fall back to LTM. And then NTLM, sorry. And then you can also set up encryption if it's supported, and then you can even get down to the detail of what kind of encryption you want to support between your communications. And those are really going to be your primary points of troubleshooting if your endpoints are giving you problems. Your authentication and your encryption are going to be probably the biggest one. And then obviously you want to make sure all your ports are on the same. And then it's going to come down to setting up that specific feature inside of SQL Server to work with the endpoint. Oh, and by the way, you can actually see endpoints here in the interface. If we head down to Server Objects, Endpoints, we have system endpoints, and then we have all of our user-defined endpoints, which we don't have any, so they're all going to be empty. But system endpoints, SQL Server does come installed with 5 endpoints because it's the only way into SQL Server to communicate with it. So we have one setup for each protocol, and then we have the dedicated admin connection endpoint. So right now, anytime we connect to SQL Server, and anytime we've been going through the TCP endpoint. Now, the last thing I want to show you here is how to work with certificates and keys. And troubleshooting isn't too bad on these. It's really just being aware of expiration dates and making sure if something ever happens that you have a backup of your certificates and keys so you can recover the data. And half the battle with certificates and keys is knowing where to look to see if they even exist on your system. And so you can use these 3 views to do that. And you can also use the interface. I'll show you where to look here. But first, let's just get some certificates and keys out there so we can find them. And I'll also show you here how to encrypt a column of data, which is really pretty useful stuff. So the first thing we need is a master key. And we're going to create all this stuff inside of our NUGA Demo DB database rather than at the server level like we needed to do with transparent data encryption. So let's create a master key here in our NUGA Demo DB database with the password supercalifragilisticexpialidocious. All right, that's a nice secure password that nobody will ever know how to spell, let alone guess. And then let's create a certificate called the Data Encrypt Cert. Give it a subject and an expiration date. All right, now we can create a symmetric key, choose our encryption algorithm, and encrypt this key with our certificate. So that's why, as I mentioned, certificates are really just containers for keys, and we're going to use a symmetric key to be associated with the certificate. So we do that, now we've got a key. So that's all we need. We've got our master key in the database setup, we have a certificate setup, and then we have our symmetric key associated and encrypted with our certificate setup as well. So now if we execute these statements here, we have, here's our key, and our certificate, and then we have our database master key and our data encrypt keys. These are symmetric keys. We don't have any asymmetric keys set up, and an asymmetric key is really just a much more secure version of a symmetric key. When it comes to doing this kind of stuff, data encryption, you want to stick with symmetric keys because the performance is incredible compared to asymmetric keys. So from here, we're going to alter our employees table, and we're going to add a social security number column to it. So let's do that. All right, that's done. Now, in order to actually put data in, we need to open our key, decrypt it by the certificate, and now we can put data into our employees table. So let's do that. Let's open the key. Then we're going to update our employees table. We're going to set Bill Gates' record here. We're going to put his social security number in it. And here's what actually does the encryption. Encrypt by key. We use the key GUID function, pass in the name of our key, data encrypt key, and then our data. And here we're just going to hard code his social security number into his employee record. So let's highlight all of this code and hit execute. That'll do the update. And now if we select everything from our employees table and we scroll over to the right, check out our social security number. It is encrypted. Pretty cool, huh? And pretty easy to do. Now let's say that we wanted to get the data out for our HR managers so they can modify and work with social security numbers. Well, what we need to do again is open our symmetric key, decrypt it by our certificate, and now we can run the decrypt by key, the exact opposite of our encrypt by key, only this time we don't have to pass in the key because it knows what it's encrypted by. We just need to pass in the column that we're decrypting, and that's it. So now we'll do both here. We'll grab the encrypted version, and then we'll grab the converted decrypted by key version as our decrypted social security number, and there it is. There's our encrypted version, there's our decrypted version. So pretty easy here to encrypt data in SQL Server. A lot easier than most people would think. But again, the key to making this all work is to ensure when you create your certificates and your keys to back them up and put them in a secure location. And also just be aware of your expiration dates because once we're past 1/1/2015, we won't be able to decrypt or encrypt anything with our certificate. We'll need to update our expiration date or create a new certificate. And also where you can find these, let's head into our database. We created all of these at the database level here. So if we go back into security, back down here we have our asymmetric keys, our certificates, and our symmetric keys. So there's our certificate and there's our symmetric key. All right, in this CBT Nugget, we got familiar with managing and troubleshooting security. We started off with how to work with permissions and securables, and we designed a security strategy around an HR department where we took a bunch of standard users, we took a managers, then we even took a power user and gave them all permission using the principle of least security here in SQL Server through database roles. We then got familiar with how to work with schemas, a great way to give access to a specific area of SQL Server, and we set up a sandbox there for our developers. And at the end here, we got familiar with how to troubleshoot some areas of SQL Server. We looked at authentication troubleshooting, endpoint troubleshooting, and how to work with certificates and keys and even encrypt data at the column level. I hope this has been informative for you, and I thank you for viewing.